Imagine wanting to build a Lego city. No, come on, bear with me on this. You want to build a whole Lego city with buildings and vehicles and little people and bridges and, shops? Sure. Anyway, so this is a pretty big project and you want to be able to do it efficiently, so let's think about what you need, aside from a Lego Death Star, because that's just, obvious. You can't just buy a whole city set, so you have to buy each of the sets for each of the individual buildings and vehicles and people, etc. And each has their own instruction manuals that need to be followed and built. Now, you may think hours are fun, but what I think is an escalating probability of either losing a piece or misreading the instructions, and I could be deep into construction before I realize I've gone wrong. Oh, no, I don't get invited to many parties. Why do you ask? So, how would you solve this? Well, the best way would be to assemble a team of builders who are familiar with each set so they could build them quickly and efficiently, so I could focus on arranging the city layout. And maybe as you go through the project, you develop your own shorthand for giving instructions to your builders, which would improve the efficiency and, more importantly, accuracy of your communication. Now, this may sound a bit too much for a Lego project, and it is, but when it comes to provisioning infrastructure for a larger software project, then honestly, that doesn't sound too bad. If you think about it, that's kind of how we organize software development teams anyway. But I can hear you now. The title of the video says Terraform. And what does that have to do with Lego? And, well, the answer is nothing. But the Lego City helps to illustrate a need in organizations. Software projects require infrastructure, often a lot of different infrastructure, and setting this up historically has been somewhat challenging, if not simply just time intensive. Just like building that Lego City all by yourself. As I often had to as a child. Terraform would be the equivalent of that team of builders, allowing you to push the automation of the provisioning process out to an external entity, which in this case is a software project specifically for managing this. HashiCorp defines Terraform like this. HashiCorp Terraform lets organizations use infrastructure as code to automate the provisioning, compliance, and management of any cloud, data center, and service, including servers, databases, and firewall policies. A pretty succinct description that I'm not going to try to beat, but let's look at how that relates to the Lego City example. The instruction manuals would be APIs, the builder's shorthand language would be HCL, and Terraform would be the group of builders as a whole. Now, what does all that mean? Let's go through it. API stands for Application Programming Interface, which is summarized as programmatic access to a website, application, or software product. This is how Terraform communicates with other applications. Things like AWS, VMware, or Azure are supported, and Terraform has providers to communicate with all of them. What's a provider, you ask? Well, I'm trying not to just say it's what Terraform calls modules, because that is kind of accurate. What it is pre-configured code designed to interface with a certain software product. Terraform has hundreds of them pre-written, as it was originally an open source product, so hopefully whatever software you're trying to use should have a provider, and even if it doesn't, you can always write one. As long as you're familiar with both the application you're trying to use and the Go programming language. So not easy, but possible. All other providers are available on the Terraform registry. This is an online repository of Terraform providers along with their documentation. Okay, so we know that Terraform accesses applications through their APIs. That's on the application side, not the user side. How do you tell Terraform what to build? How do you command your legion of Lego builders? Well, I already said the answer was HCL before, but let me explain what that actually means. HCL stands for HashiCorp Configuration Language. I know, not the most imaginative name, but it is informative. It's a JSON-like configuration language that allows you to manage the resources you want Terraform to manage. While it has small aspects of value substitution available, but that allow for some of it to be somewhat automated, the general theme is, unfortunately, that it's not a programming language, so this means that you should be able to read off what resources you want from the config file, not being able to dynamically ascertain them as you go. That came out unnecessarily wordy, didn't it? What I mean is, you have to have the values available. It can't work out what the values should be. While this may sound like a limitation, it also allows you to statically define configurations across whole networks and keep track of changes in version control systems the same way you would develop code, hence the term infrastructure as code. Now, I'm hoping you can all see the advantages of this, but I'm going to lay them out anyway just to be sure that you've got it. 1. Centralization. You can manage an entire network from one tool, rather than having to go into each machine and change the settings one at a time, as well as giving you easier visibility over any errors or misconfigurations in the network. 2. Reusability. Because you're writing out a series of instructions to be executed, it means that those instructions can be used again and again. So, once you're sure they work, you simply need to run them in Terraform to set up the whole set of resources needed in one go. 3. Speed. Terraform can set up networks much faster than a human could by going through each one manually. If you use providers right, you can even have them mostly configured by the time Terraform is done acting, which is all done at computer speed rather than human speed. This is, of course, not counting the time spent writing the configuration in HCL. 4. Clarity. HCL gives the ability to express an entire network configuration in text. Once you learn to read it, it can be viewed as almost a written network diagram, which can be very helpful for fault diagnosis and auditing. Okay then, I hear you say, I'm sold on Terraform. How can I start using it? That's a good question. A very good question. Terraform is available from HashiCorp in 3 different versions: open source, enterprise, and cloud. Open source is the free version, good for setting up small networks and road testing Terraform to see if it meets your requirements. It's controlled through the command line, and while there is a limit to how many services it can manage at once, for most small businesses, this can be perfectly sufficient to manage their needs. The cloud version is the recommended solution for most situations. It hosts Terraform at HashiCorp and is controlled through a UI that allows you to run and manage workflows with clicks rather than command lines. A workflow, by the way, is an automation of the process of running a Terraform configuration. So, maybe you want to authenticate some values or something before you allow the Terraform configuration to run. Well, workflows allow you to define those steps in the UI so they are always followed, including things like allowing for admins to have to approve each run. It's sort of like automating the automation. A bit meta. Okay. Anyway, that's the 2 main versions. The third is Enterprise, which sits in the middle of the other 2, as basically a locally installable version of Terraform Cloud for local infrastructure. This is mostly designed for organizations that require hosting of their own data, but need more than what open source can offer. The only downside is that it has less features than Cloud, so Cloud is still recommended when suitable, as it is updated more frequently. But this is a decision very much down to the requirements. So, if this sounds useful to you, have a look at the documentation on the HashiCorp website. Or get in touch, and we can help set you up with enterprise or cloud versions. We have several HashiCorp certified consultants who can help you work out what it is that you need.